and welcome to our 5-minute video on centrifugal cleaners, part of the level 3 technical tutorial. Cleaning is really important in the paper industry because it prevents wear and tear and damage to equipment. And we can either remove contamination because of its size, which we normally do with screens, or we remove things because of by virtue of the density of the contaminated material. And for density we use centrifugal cleaners. So essentially this is how it works. Fibres have got a density about the same density as water, 1-ish. By far the majority of contamination has a density much higher than fibres, and so we use this virtue of density to separate out the two. There are occasions where sometimes the contamination might be something like polystyrene. Now polystyrene is a lot less dense than fibres, in which case we will be rejecting the lighter material and accepting the heavier material. So let's move on and have a look at some centrifugal cleaners. You should be aware of these three characteristic shapes and be able to identify these. This short stubby one here is known as a sand cyclone, and these ones are dedicated for removing just bits of grit and sand that you can get in some sorts of pulp. If you look at these two, this one very solid looking, very robust, long parallel walls, very short taper. This one very short parallel wall, very long taper, a lot less robust. So the solid one is a high consistency cleaner or a high density cleaner. So that's operating where your stock has a consistency of about 2.5% or more. So a lot of buffeting, so therefore you need a strong, robust piece of equipment, and this looks very strong and robust, so that's the way to remember that this is a high consistency cleaner. This one here, low consistency cleaner, it looks a lot more fragile, so therefore you would use it in the thin stock area where there's a lot less buffeting by all the fibres. So that's the general shape of these general types of cleaners. What we need to do now is to look at more specifically at the way that they work. Three slightly different formats of cleaners here. This is the very traditional cleaner. We'll talk about this at the end, where you bring material in, heavy material gets thrown out the bottom, accepted light material, the fibres come out the top. That's the traditional one. People have moved on, and cleaners are getting a lot more complicated now than they used to be. This is one of the most modern cleaners, and this one here is what we call a combi cleaner. It's called a combi cleaner because it doesn't just do one separation, lightweights and heavyweights. It actually does two separations, heavyweight rejects, lightweight rejects, and accepts. So we bring stock in from the side, tangentially, it whizzes around, the heavy material gets thrown to the outside, slides down the wall, falls at the bottom, there's your heavyweight contamination. The lightweight material, which is what you want, will then turn around on itself and come up here, but there's a mechanism then for separating out the very light contamination from the lightish fibres. So you've got three exit streams there. Heavyweight contamination there, lightweight contamination there, accepted fibres there. This is an unusual configuration, you don't see many of these around. This is known as a forward cleaner or a uniflow cleaner. And the odd thing about this is the stream of stock does not turn around on itself like in all the other designs. In this case, everything goes in one direction, so uniflow, one flow. You bring the stock in at a tangent, it whizzes around, and the mechanism for separating out the contamination from the accepts is all done at the bottom there. And then we now move on to the oldest, most established, most common cleaner. And this is known as a reversed cleaner. And it's called a reversed cleaner because the stock reverses direction. So we bring stock in from the side at a tangent, it whizzes around, the heavyweight materials or the high density material gets thrown out to the sides, hits the sides, drops down the bottom. The stock that we want then reverses direction and comes back up and then out through the top. So that's why it's called a reversed cleaner, because the stock that we want reverses direction. Exactly the same design, but if you use it not for separating out heavyweight material from fibre, if you use it for separating out lightweight material from fibre, like polystyrene for example, then we call it a reverse cleaner, reverse without the D on the end. So that's a very important difference, no D on the end. A reverse cleaner operates in the reverse direction. A reverse cleaner will be used to separate out, say, polystyrene from fibres. So if you think about the density, fibres are now the heavy material, polystyrene is the light material. So we bring the stock in from the side, it whizzes around and around, the more dense fibres get thrown to the outside, slide down the walls, so the heavyweight accept is this time fibre, and the lightweight is the reject coming out the top. That is the polystyrene. So you should be aware of the difference between reverse cleaners and reversed cleaners. That one D makes a big difference. If we look at how cleaners work, we bring the stock in, as I keep repeating, at a tangent. We make it spin around, and just like if you're driving a car going round a roundabout very fast, you will feel yourself thrown against the wall of the car or the door of the car. So it's the same idea. You bring in the fibre, the stock, you make it spin around, the most dense material travels fastest to the outside, it hits the wall, and then it slides down and will fall out the bottom. The lighter weight material is about the same density of water. That actually gets sucked into the vortex. And in this case, we actually have some dilution water being introduced that will then carry the water, the centre of the vortex, up and out through the accepts. So that's the basic principle of centrifugal cleaners. We don't use them in wands, we usually use them in banks of cleaners. There's a picture taken from, I think that's from Aylesford Mill when it was still running at the time. And as you can see, we have a whole series of these cleaners. So we will bring stock in, pass it through each of these, accepts out the bottom, sorry, rejects out the bottom, accepts out the top. Whenever we do drawings and whenever we show particularly do drawings, we always show them vertical. There's absolutely no reason why they have to be vertical. Depending on your space, we can have them at, you can have them horizontal, you can have them at 45 degrees. It's whatever's convenient for your mill. It's this spinning action within the device that matters. So the orientation of the centrifugal cleaner is irrelevant, really. We normally use cleaners in banks. If you're a virgin fibre mill, you might just have one bank of cleaners, maybe two, possibly three. One and two are the most common. If you're a recycled fibre mill, you could easily have more than 7, you could have 8 or 9 banks of cleaners. The purpose of the first bank of cleaners is to do the more severe cut, reject a lot of the contamination, but also reject a lot of fibres. So you're absolutely sure that you've got good, almost contaminant-free fibre going forward to the machine. Every other bank of cleaner that comes after that is there not to reject material, but to try and catch some of the good material that we threw away and put it back into the previous system so that we can go around again. And as you'll see, you've got a lot of cleaners there. You've now got less flow, and therefore you'll need less cleaners coming to this one. You'll accept some of that. You've got less flow, so you'll have less cleaners. Again, accept some, less flow, so less cleaners. So every bank of cleaners has less cleaners than the previous bank. And they're all there, all these are there to recover good fibre that you threw away and put put it back into the system. Why do we clean? Well, we clean to prevent wear and damage to equipment, to prevent wear and damage to pipes, and also to prevent contamination reaching the sheet and giving you a sheet with dirt specks or who knows what involved. This is the sort of material that we can get out of cleaners. So there's bits of wire, staples, screws, washers, nuts, broken glass, a whole variety of material. So a summary of what we've talked about today. Cleaners separate by density. Low consistency cleaners, tapered, operate at less than 1.5%. High consistency cleaners, long parallel walls, operate above 2.5%. Cleaner orientation can be vertical. I've seen it horizontal. I've seen it at 45 degrees. The higher the consistency, the poorer the separation, because the contamination has to work its way through those fibres. As the diameter of the cleaner decreases, then the velocity of the stock within the cleaner increases. And finally, cleaning reduces wear, reduces damage, and reduces contamination. Thank you for listening to this tutorial, and you can find us on all these social media.